Okay, let's look at this DocSci exercise 24. It's the first titration calculation in the book, and it's just we're going to end up using this titration formula to solve it. A standard sodium hydroxide solution is prepared by dissolving 8 grams of sodium hydroxide in distilled water and filling up the container to 400 cubic centimeters. The standard solution is used to determine the concentration of a sulfuric acid solution. Exactly 20 cubic centimeters of the base neutralizes 15 cubic centimeters of the acid. So this exactly word is what tells you that you can use the titration formula. If it's not exactly, you can't use the titration formula. So let's go ahead and calculate the concentration of the standard solution. So for concentration, we usually use C equals N over V, but we've been given a mass here. Okay, the sodium hydroxide is 8 grams of sodium hydroxide. This is a mass. So I would rather use this formula. If you use this formula, you need 2 steps. You need to go N equals M over M, and then you need to go C equals N over V. But if you do C equals M over MV, it's 1 step. So the first thing we have to do is find the big M for the sodium hydroxide, okay, the relative molecular mass. So it's 23 for the sodium, 16 for the oxygen, 1 for the hydrogen, which is going to give you 40, okay. Then you must write the formula every time. So C equals M over big M V. Okay, so my C is going to be equal to my mass that they gave you is 8 over big M, which is 40, and now we want to multiply it by, how much did they put it up to? 400 cubic centimeters. So 400 cubic centimeters is 0.4 cubic decimeters. So if we have our calculator ready, like we're supposed to, I get something wrong. I've pressed the wrong button. 80 divided by, I've got 0.5 if I press the button right. 0.5, and my unit is moles per cubic decimeter. Okay, moles per cubic decimeter, and we know for sure it's in cubic decimeters because we converted the volume that we had. We converted the volume to moles per, to cubic decimeters. This 400 cubic centimeters we converted to cubic decimeters. Now it says write a balanced reaction equation for the neutralization reaction that occurs. So sulfuric acid plus sodium hydroxide goes to sodium sulfate and water, and acid plus a base gives you a salt and water. What you need to realize is to balance it, you've got 1 sulfuric acid to 2 sodium hydroxides to make this Na2SO4, because the sodium cation's only +1 and the SO4 sulfate ion is 2-, so that's how you balance it. Okay, so now it says calculate the concentration of the acid. So we can do this using this stoichiometry formula. The concentration of the acid times the volume of the acid equals the concentration of the base times the volume of the base equals the number of moles of the acid over the number of moles of the base. So we're going to get the number of moles of acid over the number of moles of the base from the balanced equation. Okay, so I can't type into this equation nicely, so you're just going to have to figure out what we're doing here. So the top of this equation is CAVA. CA is what we're looking for. Okay, we don't know CA, but we do know the V of the A. It's 15. Okay, now this formula, because it has got these two are comparing with each other, we can keep the units as whatever they are in the question, so long as the units are all the same, okay, and that the unit we're trying to find is in the correct mole per cubic decimeter thing. So it's like the gas law questions, where as long as all the units in the equation are the same, because it's a comparison, it's going to work out fine. So now we need the concentration of the base, which is 0.5 times the volume of the base, 20 cubic centimeters of the base, so we can just put the 20 in because it's this type of formula, equals, so I've got CA VA over CB VB equals, we need Na over NB, the number of moles of the acid is 1, oopsie, okay, it's 1 because there's no coefficient, so we know it's 1, and it is over it is over 2 because there are 2 moles of the sodium hydroxide. So if you do all of this, okay, you should end up with, if you multiply this out, you should end up with a concentration of the acid being equal to 0.33 moles per cubic decimeter. And because the other one is in moles per cubic decimeter, the other concentration that we put in the formula, see this concentration that we put in the formula and this concentration, these two will be the same units in the final answer. So you should end up with 0.33 moles per cubic decimeter.